If you've been searching for exactly how to determine newel post placement and height, then this video was created just for you. Welcome to the channel, folks. I appreciate you being here. There just isn't much detailed information on how to determine the placement and height of newel posts. This video is intended to provide a detailed explanation on how to do this. Let's face it, newel posts are expensive, and if cut incorrectly, the newel is wasted. Worse yet, if you incorrectly cut it and then install it either too high or too low, it will fail the building inspection, which of course will compound not only the cost of the newel, your time, and a major delay to the deadline and the completion of the home and the all important CO or certificate of occupation. The intro videos we just been watching and this picture that's been up on the screen for a minute are indeed a set of stairs I just finished. Very important to come up with a plan of attack on what needs to be done first and what needs to be done last when you're working stairs. And I just will quickly go over the order in which I work these stairs. The first and foremost would be the skirt boards on the closed sides. In other words, where they're not open or mitered but closed by either that knee wall on the left or the wall on the right. That's the first thing. Then we went on and we put all the closed risers and treads in, and we'll go over these terms in more depth in just a minute. Cap the knee wall, full open mitered skirt boards, which are the ones that you'll see that actually touch the landing. Those are mitered. They take a bit of time, but again, not complicated. I did the open risers and treads, the intermediate landing newel connected to the knee wall, so that'd be the post or the newel connected to the knee wall that's going to connect the starting newel that we're going to discuss today and the rosette at the top of the stairs. Then the starting newels at the bottom, and I'll explain why I do that second, to the intermediate landing newel, the rosettes for terminating the handrail on the balconies, and the handrails themselves, the balcony balustrade, and then I tackled the rake balustrade last. All right, we are at a diagram that I've created. This is a full scale diagram of a stair layout, and we're going to go over the terms, what each of these mean, and relating to how to set this first newel post. And by the way, I didn't say it, but this video is for setting the starting newel. I will do other videos on setting the intermediate landing newels and the balcony landing newels and things like that. But if you understand the concepts of what we talk about here today in determining the location and height of this starting newel post, then all the other explanations are easier to understand. And it just is kind of adding to your knowledge of stair building. So if we zoom in, I'm going to do a lot of zooming in and things like that, and I'll explain what I'm doing. We'll look at the key. We have a rail height code, which is in the dark pink, and that code in this example is going to be 35 inches. Um, in my area, it's 34 to 36, and we usually shoot for 35 for any variance so that we're not below the 34 or above the 36 if we, or vice versa, if we get off on that just a little bit. Because the things that I can't control the stringers that are already built. I can't control, I can to a little bit, but I really can't control the riser height to a great extent or the overall run of the stairs. So I'm kind of stuck with what I have to work with from the framers. We have excellent framers, and they do a great job, and I usually have no issues. So the real height code of 35 is what we're going to shoot for. The blue is the handrail, green is the rake. You'll understand the reveal on the newel post in a minute, and then just any pencil markings that you see. But for sure, don't use this as a exact way to do it as far as the codes go. Always check your local building codes. And then moving down here to what we're going to be dealing with, the diagram that I set up is, again, I'll say it's full scale. The rise is 7.5, the run is 10, tread overhang is 1.25, the rake angle, which we'll go over, is 36.8, and then we'll go over the math behind some of this later. So the tread overhang, I'll zoom in a little bit so you can see it better, is actually the distance from the front of the riser to the extent the tread hangs over the next tread. So in this case, it's 1.25. The rise is calculated from the top of one riser to the top of the other riser, and that's 7.5. And the run is calculated from the very face of the actual installed riser to the face of the next installed riser. So that's the run, and that's 10 inches. And then here's our rail coat height. Let me zoom out a little bit. That is from the very tip of the tread, which is down here, to the very intersection of the top of the handrail. In this case, if I click on, let me unlock it first. Oop, turned it off instead of unlock it. If I click on this, and I've got it grouped, so let me ungroup it and then click on it. You'll see up here in the top left that that is indeed a 35-inch rail height measurement. So let me set that back and then lock that key and then close this temporarily. Sorry about all the jumping around and opening pallets and things like that. It's just part of me doing this demonstration, but we'll get through it. So here's the example, and I will just go over it once again. This is represents the handrail on that rake, that angle, the rake angle. This represents the rake angle as placed on touching the very tips of the tread overhang, which again transfers that angle so that you can see it on the post itself, and a floor base, which is this gray line down here. If I go to another page and I show you the logic behind this thing. So once you determine the stair angle, which we'll talk about briefly on how to do that, this video is not about that, but anyhow, this is the angle you just saw, and this is the handrail. The height of this handrail is 2 3/8 inches high. Then the handrail on the miter saw is cut to the angle, which is that, what was that? I forget. 36.8. When you cut the handrail on 36.8, it will actually lengthen the distance of that handrail as it will appear on the reveal. So we started out with 2 3/8. This is an exploded view or enlarged view of the handrail. And then I went over here and I measured it electronically to come up with what the actual length or the height of that handrail is on the angle. And so it went from 2 3/8 to almost 3 inches. So I'll call that 3 inches up here in the top left. If you were doing this in a real world situation, like I did the staircase illustrated in the photos in the video, you'd simply take the handrail to the miter saw, cut it, and then measure the length of that cut on the angle. That's all you do. Very simple. I just couldn't obviously do it here. So, and then let's talk about the reveal on the Newel post. So I've marked the reveal here in gray, and that I just rounded that off to 3 inches, and that represents that angle we've just now been discussing and where that's going to intersect the rail at the proper rail height code of 35 in this example. So that's what that's for, to let us know that we're in that ballpark. So if you're dealing with just a square post with no detail, it's not a big deal. The post in the video were square posts with a a crown top or whatever you want to call it, a bevel top. And in most of my cases, I do have detailing and I do have a reveal that's very specific. So it's very noticeable if that reveal is off, high, or low from the handrail. So just wanted to mention that. I just wanted to step back a second and introduce you to a very, very helpful stair building construction guide. And this is from the W.M. Kaufman Company. That's the stair building guide that they put out. It's an excellent resource. I keep it on my phone, of course, on my laptop, and I have a hard copy I keep in my toolbox. It's excellent. It shows you, explains all the basic concepts, the starting position of the newels, intermediate landing newels, balustrades, the whole works. So we're going to go through this. We're primarily going to focus on a couple of pages, and it's a lot of what we've been talking about already. I won't go over it again, but it talks about local building codes, the rake rail heights, balcony heights, how to determine the rise, the run, tread overhang, things like that, why the codes are specified the way they are, how the building inspector will use this round sphere shaped ball to determine if you've done your job correctly. It's kind of unnerving when the inspector comes in with this little ball and actually sticks it to your your balusters on the balustrade, checks your rake angles, checks your handrail height. You know it's right, but it's still a little unnerving. So that's that page. Then if we go down to page, I think it is 13, this will discuss in detail the Kaufman explanation of it is, which the Kaufman way is just the industry standard way. It's not something they invented, but they've taken industry standards, applied it to their products, and the whole reason for this book is twofold: to teach and be a resource, and it's also to help you order their products correctly. If you're going to order a starting newel, what height would you get? What block height would you get? If you're going to an intermediate landing uh, post newel, what you would do there. Uh, One of the biggest helps this thing has been to me, among others, is understanding the relation, the one-to-one relation of the standard position, which is placing the newel center of the riser, and this shows standard placement here. Um, and it also shows the one-to-one direction. If you move the newel in this direction, what happens? And if you move the newel in this direction, and if you noticed in my photos and videos of the staircase I did, I'm in a non-standard position. The cool thing about all this is if I understand the concept behind what the standard starting position is, center of the riser, then I can figure out what my non-standard position height and would be based on the placement, and it explains all that. We'll go over this in detail in the real world example back in the diagram, but it shows you the math. It's actually a math formula that will show you how to do it. So it's basically the rise, whatever that is. In our case, it's 7.5 divided by the run, which is 10 in our case, times the distance moved, how far you move the newel post, will determine the height that the newel post has to be off of the starting newel height position. And I just wanted to show you that this is an excellent, excellent resource, especially if you're starting out learning. But it's also an excellent resource if you want to reference things that you may or may not do, um, you know, a lot, but you're going to have to do in the future or at times. And so this is also, I wasn't planning on showing this, but this is page 11. This is an intermediate landing newel. You'll notice that, as this handrail right here I'm clicking on, as it goes down, it's going to go down to probably a starting newel. The starting newel is going to go up to this intermediate uh, landing newel. And if you notice, the block height here is much larger. And that is to account for the next full rise of steps that's coming into play as this handrail turns and goes up to, say, a balcony. So this would be intermediate. Balcony landing newels, you can see that it's not nearly as big here because you're not going up as much. The balcony intermediate newels, which we talked about, and it shows lots of different kinds of placement options and standard placement options. So this is extremely helpful. I can't stress it enough. All right, let's get at it. Let's cut us some newel posts and see if we get it right. We're going to zoom in on this guy here. Close this temporarily. So we're going to illustrate determining newel post height from the standard position. So in the real world, I've seen guys notch this post so they can get it in position. Obviously, the notch is going to be at the wrong height once we cut the bottom of this post off for the correct height. So what they'll do is they'll notch it temporarily so that they can put it in this position. They'll find out where the rake angle intersects the newel post, because that's where you're going to measure from. You'll see in a minute. And then they'll get that measurement. They'll measure down from the reveal that we talked about earlier, the top of the reveal, down to that mark, and they'll subtract whatever that is from the intended target rail height of 35 in this case. Then they'll go back, and once they cut the bottom of the newel post off, they'll recut this notch to fit in the correct position for this starting position of standard. So, and that's a lot of work. If you know that you're going to have a starting position of standard, there's some things you can do to figure this out without having to make the notch. So if we look at this, and I'll turn on my example here to explain it, we have two red boxes. I'll hide this one temporarily. This red box represents the edge of the newel post to the center of the riser, which is just a little bit off center of the post, but don't get hung up on that. It's actually marking the position of where that riser intersects that post starting from the left position. And that's based on the rise. So we know that rise is 7.5 because we determined that, went over that earlier. And by the way, this diagram represents the measurements shown in the Kaufman Stair Guide. So that's a good measurement. It's a figure that we know we can rely on of 7.5 of rise, and then we go ahead and add from that intersection or that point on the right out to the tread overhang, which we know from the previous video that tread overhang is 1.25. So those two blocks together tell us where we can start to intersect this rake angle without this post being notched. So in order to do that, we go back to 36.8 because we know that's our rake angle, and I have created for us a visual reference of a speed square. And we're going to use that speed square to determine where all these measurements will be based from. So if we take this guy and we take this square for reference that we just made, and we're going to pretend we're going to take this over to the miter saw or our work table and figure this out. So I'm going to copy this down to represent us going over to the table. I'm going to go back because I messed up there, and I'm going to copy my digital speed square. In reality, this would be laying on your work table, much like this. You would take your speed square, put your pivot point, put your pivot point on the edge of this post. Uh-oh, I screwed up there. I'm going to have to take this little bitty square and move it down because I forgot it. Or it got left behind, poor thing. So I'm going to move that down. Position it back where we had it. Then take my speed square, Sorry about this, folks. Sometimes things happen on video. Put my square pivot point on this post on the edge, and then I'm going to pivot my speed square into the position that it already is, which is 36.8. And then I'm just going to move this guy down until I intersect the tip of where the combination of rise and tread overhang intersect. So that's eyeballing it, just very much like you would do in the real world. And now that I've got that down there, I can then measure from the top of the reveal. Hopefully remember the top of that reveal is where the top of the handrail is going to intersect. And I can take my pencil and simply draw a line down to where that intersection is going to be. So you're looking at the bottom of the speed square on the angle of 36.8 where it intersects our reference points. So in reality, these red boxes would just simply be a pencil line that you would draw across here to indicate where you want to place the speed square. Now I've got this line kind of off because I couldn't see. So I'm going to click on that sucker and I'm just going to eyeball it up to there. Obviously you wouldn't be going through this torment in the real world. And I apologize for jumping around on you, but I want to get that pencil mark as close as I can. So we've got the pencil mark, once again, starting at the top of the reveal, measuring down to where our known intersection point is with our speed square. If we take that and we click on that pencil line, it's going to be 41.5 inches. If you're looking up here at the top left, you can see the length of that pencil mark is 41.5. So I'm going to make a note of that. 41.5. I'm actually making a note on a piece of paper. I'm going to go to my calculator and I'm going to clear that thing out. And I'm going to take 41.5 minus 35, which is our, remember 35 is our code height for our handrail height. And I'm going to find out what that is. So that's 6.5 inches that I need to remove from this post. So if I go back by the magic of digital diagrams, and I take the bottom of this post and pretend we're over at the miter saw, and I'm just going to minus 6.5 inches off the bottom of that post. Then I'm going to move that post in position. Whoops, moved it just a little bit. Let me try it one more time. So if we look now at the intersection of the handrail to the newel post, we're pretty much hitting. I'm off just a tad, but you're talking maybe a 1/16 of an inch. But here's our reveal in the gray part. It's there to show us where the handrail is going to hit at the height that we cut the newel post to be. So that, based on the standard position, is how we got the intersecting points, how we knew where to put the speed square, how we knew to mark a line down in the correct position. Remember, it was the bottom of the speed square where that rake angle was going up. And through those simple measurements, we know with confidence that now we can go back and notch this newel post, put it in position, secure it, and that our handrail is going to hit at the right height when we install the full handrail. So that's how the standard position works. Okay, what about the non-standard position? So we're going to take this newel post and we're going to move it. Let's just pick, we're going to have to pick a measurement because I would do that in the real world anyway. So I'm going to turn on my guide so we can see what's going on. I'm going to place a guide to the left face of this newel post because that's what you would do if you were measuring it. And then I'm going to say I'm going to move that newel post like in our video. We're going to move it out that far. So we are going to move it from this blue guide here over to this blue guide. And normally I would have a measurement on the floor and I'd measure that. In the digital world, I'm going to zero out to this guide and it's going to be on 0. And then I'm going to figure out exactly what that is. So that turns out to be 6 1/4. So we're going to be moving that newel post to a non-standard position by a measurement of 6 1/4. So let's go ahead and do that. So there it is. Oops. Man, I keep doing that. All right, let's do it one more time. So that's 6 1/4 over. So we moved it from this guide to this guide, 6 1/4. We're still concerned about the rake angle, obviously, because that's going to determine the height that this newel post has to be. So if you reference the Kaufman Stair guide, you'll notice that if I move it in the direction we just moved it, I'm going to have to obviously shorten this newel post to get it now to hit on the handrail angle of 36.8. So how do I do that? Well, I could lay my 8-foot level back up here, put it on the nose tread tips, or the nose, I'm sorry, the nose of the treads, and then just take a pencil and mark it. And that's actually how I did it because I started out with a non-standard position, but we're starting from the standard and figuring out what the new newel post height would be to the non-standard. So that's where we go down and we'll look at our math. So we're going to take the rise divided by the run times the distance moved equals the newel post height adjustment. So if we go back to the calculator, we're going to take the rise of 7 1/2 times the run, which is 10. I'm sorry, let me do, I did it. I think I did it wrong. We'll take the rise, which is 7 1/2, divided by the run, which is 10, times the distance moved, which was 6 1/4. And that's going to equal 4.6875. All right. And that's the measurement that we have to take off of this newel post in this new non-standard position. So if I go down here, same thing, and I minus 4.6875, I'm up here in the left-hand corner, by the way, up here. It's going to take off what we need from that newel post. And now, if I move the newel post back into the non-standard position, touching the floor, we now have the correct position of the handrail on the newel post. And that's pretty much it. My gosh, we have gone over a lot of material. Please drop a comment below. I always answer them as quickly as I can. I always respond. I always love answering your questions. And also, if you have any tips, I definitely am not a master carpenter. I definitely am learning on every single job I do. And I would appreciate any tips and tricks that you could pass my way. Again, thank you for watching. I appreciate it. If you like this video, please like it. If you feel in your heart that you got a lot out of it, please consider subscribing. I'm trying to get to 1,000. I don't want to beg, but 1,000 is pretty important landmark to make in the YouTube world, and I'd appreciate it very much. Thanks again.